Hello students, welcome to Software's classes. Today we will be solving the CSIR UGC NET questions from the June 2018 paper. We will be solving the set C of the Mathematical Sciences paper. Let's start off with question number 69. In question number 69 it has been said that which of the following functions are of the bounded variation? Option 1, x square plus x plus 1 for x which belongs to the open interval minus 1 to 1. Option 2, tan of pi x by 2 for x which belongs to the open interval minus 1 to 1. Option 3, which is sine of x by 2 for x belonging to the open interval minus pi to pi. And option 4, root over 1 minus x square for x which belongs to the open interval minus 1 to 1. So before we start to delve into the problem, let us understand that what is the meaning of a bounded variation. So bounded variation is basically a function f is bounded variation if f is continuous on the open interval AB and also if f dash is bounded on the open interval AB. So these are the two conditions for a function f to be a bounded variation. So now let us start off with option 1. In option 1 it has been given that f of x is equal to x square plus x plus 1. As we know that this is a polynomial. And polynomials are always continuous everywhere on the real number set. So therefore fx is continuous on minus 1 to 1. And now if we find out f dash is equal to twice x plus 1, which is bounded on minus 1 to 1. Okay, this is also we know. So therefore we can write that therefore f of x equal to x square plus x plus 1 for all x which belongs to minus 1 to 1 is a bounded variation. So that implies that option 1 is correct. So option 1 is correct. So now in option 2 it has been said that f of x is equal to tan of pi x by 2 for all x which belongs to minus 1 to 1. We have to check out whether in this interval f of x is a bounded variation. Now there is one more condition that we need to keep in mind, that if limit f of x as x tends to c is equal to infinity for any c which belongs to the closed interval AB, then f is not of bounded variation on the open interval AB. This is the statement that we are looking for. So now here if we put x equal to minus 1 or x equal to 1, if x is equal to 1, then that implies f of 1 will be equal to tan of pi by 2, which is equal to infinity. And if x is equal to minus of 1, this will give us that f of minus 1 will be minus of 10 pi by 2, which is again equal to minus of infinity. And as you can know that minus 1 and 1 belong to the closed interval minus 1 to 1. So therefore by using the condition that we have already mentioned, we can say that f of x equal to 10 of pi x by 2 is not bounded variation on the open interval minus 1 to 1. So therefore option 2 is false. Okay, so this is for option 2. Now let us shift our focus to option 3. In option 3 it has been said that we need to find out for, let me check the f of x is equal to sine of x by 2 for x belonging to the open interval minus pi to pi. So now here it has been given that f of x is equal to sine of x by 2, and the interval that has been given is that x belongs to the open interval minus pi to pi. So between minus pi to pi we always know that sine of x is continuous on minus pi to pi. It is continuous on minus pi to pi. This is our first thing. Now let us find out f dash. So f dash is equal to 1 by 2 cos of x by 2, and we know that this is bounded on minus pi to pi. So therefore we can say that fx is continuous on minus pi to pi and f dash is bounded on minus pi to pi. So therefore f x equal to sine of x by 2 is a bounded variation on minus pi to pi, and therefore that implies that option 3 is correct. Option 3 is correct. Now we'll shift our focus to option 4. Now in option 4 we have been given that f of x is equal to root over minus of 1 by x square for x belongs to minus 1 to 1. So let me insert another page over here to solve this very problem. So we have been given that f of x is equal to root over 1 by x square, and the interval that we have been given is that x belongs to the open interval minus 1 to 1. So now we know that this very function f of x is equal to root over minus of 1 by x square. So this function is definitely continuous on the open interval minus 1 to 1. Now let us find out f dash x. So f dash x is equal to minus of x upon root over 1 minus x square, and we know that this is bounded on minus 1 to 1. So therefore we can say that f of x equal to root over 1 minus x square is a bounded variation in minus 1 to 1. So therefore option 4 is also correct. So therefore the correct options are, we have already seen that option 1 is correct. So option 1 is correct, option 2 is false, option 3 is correct, and option 4 is also correct. So the correct options are 1, 3 and 4. So today we have solved question number 69 from the CSIR UGC NET question paper of June 2018. We will be solving the next questions in the subsequent videos. Till then, keep watching Softsource Classes videos for more solutions and content. Thank you very much.